All right, today we're going to tackle a classic, an absolute monster of a system design problem. How do you build a system that can reliably send 1 million notifications every single second? You ever wonder how a company like Meta or Uber can ping you with an instant message or a ride alert at the exact same time as millions of other people? Well, that's the challenge we're unpacking. It's a foundational piece of tech for pretty much every major platform out there. And seriously, once you start looking, you see them everywhere. We're talking order confirmations, password resets, breaking news alerts, friend requests, you name it. They're basically the digital heartbeat of how companies engage with you. But we're not just designing for a trickle of messages. Our target today is a system that's tough enough to handle a peak load of 1 million notifications per second. I mean, think about that. 1 million every single second. That is a crazy scale, and it's going to require some serious engineering. So, how in the world do we build this beast? Here's our game plan. First, we got to set the ground rules. Then, we'll sketch out the architectural blueprint. We'll follow a single notification from start to finish, see how the system holds up under pressure, and then we'll wrap it all up with the core design principles. All right, section 2, the ground rules. Now, before we even think about drawing a single box or arrow, we have to know the rules of the game. What does this thing actually have to do? And how well does it have to do it? This is what we call requirements gathering. And we basically split these rules into two big buckets. On one side, you've got functional requirements. That's the what. What features does it have? On the other side, you have non-functional requirements. That's the how well. How fast is it? How reliable is it? Okay, so functionally, think of this thing like a Swiss Army knife. It's got to support sending messages through a bunch of different channels, right? Email, SMS, push notifications. It needs to know the difference between a critical transactional message, like a receipt, and a promotional one. And it needs to be smart, letting you schedule messages, limiting how many you send so you don't spam people, and of course, retrying if a message fails. And then there's the performance side. And whoa, our goals here are not small. It has to be highly scalable to hit that million per second mark. It needs high availability, which is just a fancy way of saying it can almost never go down. Reliability is non-negotiable. We have to guarantee at least once delivery. And finally, it needs low latency because a notification that arrives 5 minutes late is pretty much useless. Okay, section 3, the blueprint. Honestly, the best way to wrap your head around this whole thing is to think of it like a super high-tech digital post office with different departments that are experts at their one job. So every single request, it starts its journey right here at what we'll call the notification service. This is the front desk of our post office. It's the API that takes in the request, makes sure all the info is there, and checks its ID to make sure it's legit. Now, once a request is validated, it doesn't go straight out for delivery. No. It goes into a notification queue. This is our mail sorting room. It's a massive buffer that can soak up huge traffic spikes. And this right here, this little buffer, this decoupling, it is the absolute secret sauce to making the whole system scale. And from that sorting room, the messages go to our channel processors. You guessed it, these are our mail carriers. We've got specialized workers for each route, a team for email, a team for SMS, a team for push notifications. They just grab messages from the queue and take care of the final send-off. All right, so we've got the blueprint. We know the main parts. Now for the fun part. Let's actually follow one single notification on its entire journey, from the moment it's created until it hits your phone. It all kicks off with a simple API request. It'll probably look something like this JSON right here. It tells our system everything it needs to know. Who's it for? How should we send it? In this case, both email and push. And of course, what's the message? Okay, let's walk through this. Step 1, ingestion. The front desk gets the request, checks its ID. Step 2, preference check. This is huge. Before we do anything else, we check, does this user even want this message? Have they opted out? Next up, step 3, formatting and queuing. The system makes a special version of the message for each channel and drops it in the right sorting bin, or queue. Then, step 4, processing. Our mail carrier, the channel processor, grabs it. Step 5 is the actual delivery. This is where we hand it off to a third-party service like Twilio to actually send the SMS. And finally, step 6 is logging. We record whether it worked or not. Simple as that. Okay, so the basic path is there, but making it work for one user is easy. How do we keep this thing from just collapsing when a million requests hit it at once? That's what this section is all about, designing for failure and for scale. So, Let's talk about the thing that's going to happen all the time. What happens when a delivery just fails? Maybe the third-party email service we use is down for a minute. Do we just drop the message on the floor? No way. We are not just going to give up. But we're also not going to just spam the failing service. That's a rookie mistake. We use a really smart strategy called exponential backoff. We wait a second, then try again. Still fails? We wait 2 seconds. Still fails? We wait 4 seconds. You get the idea. We give the other system time to breathe and recover.
Okay, but what if it still doesn't work after a few tries? Do we just throw the message away? Absolutely not. That could be a critical receipt or password reset. Instead, we move it to a special place called a dead letter queue, or DLQ. It's basically a holding pen where an engineer can come and investigate what went wrong without losing the original message.
And to handle that just insane volume, we use a powerhouse trio of techniques. First, horizontal scaling. If our email processors are getting slow, we don't make them bigger, we just add more of them. Easy. Second, sharding. Our user database can't be one giant slow thing, so we break it up, or shard it, across lots of smaller databases. And third, caching. For stuff we need all the time, like user settings, we keep a copy in super fast memory so we don't have to hit the database every single time. All right, we've made it. We've built the system. Now let's zoom out for a second and boil this all down. What are the big ideas here that you can take with you for pretty much any big system you're designing? Okay, let's just nail these down. Number one, and this is maybe the most important, decouple everything with queues. It's the secret to scaling and surviving failures. 2, specialize your workers. Let the email team handle email and the SMS team handle SMS. 3, design for failure from the very beginning. Expect things to break and have a plan with retries and DLQs. 4, respect the user. Check their preferences early and often. And last but not least, monitor everything. If you can't measure it, you can't fix it.
And there you have it. That's the blueprint for designing a notification system that can scale to the moon. But it leaves us with one last question for you to think about. With this system built, where do you put your energy next? Do you focus on making it even faster, shaving off milliseconds, or do you try to make it cheaper to run? That's the constant trade-off in system design. Thanks for diving in with us.